Okay, 16, find the antiderivative of x sine of 3x. So, okay, so once again, you tried when you do antiderivatives and you're not sure how to start, do algebraic method. Okay, we can't really simplify this. Use substitution. Well, if we let u be whatever's inside the function, that would be 3x. du is 3 dx, and 1 over 3 du is equal to dx. So I'm not going to be able to cancel this x. So the other way would be integration by parts. Okay, so I either can do the shortcut or the long way using the formula. So to determine if I can use the shortcut, I have to see whether u is going to go to 0 or not. So the way I determine u is by using LIPET, remember logs, inverse trig, polynomial, exponential, and trig. So polynomial is before trig, so I'm going to let u be x and dv be 3 sine of 3x. So x will eventually go to 0. So I'm going to use the shortcut. So the derivative of x is 1. The derivative of 1 is 0. The antiderivative of sine of 3x is negative 1 over 3 cosine of 3x. The antiderivative of negative 1 over 3 cosine of 3x is negative 1 over 9 sine of 3x. So we're going to have plus, plus, minus, plus, cross multiply. So my antiderivative is going to be negative x over 3 cosine of 3x. Negative and negative become a positive 1 over 9 sine of 3x. And do not forget the plus c. 17 says solve the initial value problem when y is 3 and x is 1. So solve the initial value problem basically says find the antiderivative, but you're going to use these numbers to find me c. So we're going to find the antiderivative. So I'm going to go ahead and rewrite this as negative x to the negative 2 minus 3x to the negative 4 plus 12. Just to make it easier to find the antiderivative of each term. So the antiderivative of x to the negative 2, remember we're going to add 1. So that's going to be to the negative 1 divided by the new exponent. Bring down the negative 3 down because it's a coefficient. So we're going to add 1. Negative 4 plus 1 would give me negative 3 divided by the new coefficient. And the antiderivative of 12 would be 12x. And don't forget your plus c. So we end up with y is equal to 1 over x plus 1 over x cubed plus 12x plus c. Okay, so that is my general solution. So now what I'm going to do is I'm going to substitute x and y. So x was 1 and y is 3. So I'm going to have 3 is equal to 1 over 1 plus 1 over 1 cubed plus 12 times 1 plus c. So I have 3 is equal to 1 plus 1 plus 12. So that's 15, 14. Subtract 14, so I get negative 11. So my solution is going to be y equals to 1 over x plus 1 over x cubed plus 12x minus 11. Okay, number 18 says the motion of a particle in a straight line is given by this. The speed of the particle is decreasing for. So remember that a particle is decreasing when the acceleration and velocity are different signs. Okay, so I need to figure out where the velocity and acceleration are different signs. So I'm going to take the derivative. Set it equal to 0. I'm going to factor out a 3. Okay, factor. Okay, so t is going to equal to 2. So checking my first derivative, I'm going to check to the right of 2. So I'm going to do 0. And I'm checking my first derivative. So to the right of 2, I'm going to have a negative and a negative. So that's going to be a positive. Okay, so I'm going to check 3. So again, I'm going to have a positive times a positive. So that's going to be a positive. Remember, when you're done, erase those. So then what that tells me is that my velocity is increasing for all values. So now I'm going to find the second derivative, which is acceleration. So I'm going to have 6t minus 12. So 6t is equal to 12. So t is equal to 2. So once again, I'm going to check 2, but this time I'm going to check my second derivative. I'm going to be checking the second derivative. So I'm going to check 0. So once again, 0 minus 12, that gives me negative. And check 3. 3 times 2, 6 times 3 is 18. 18 minus 12 is positive. Okay, so this is, if we put them right next to each other, okay, the part that both are opposite signs would be when x is less than 2. So when x is less than 2, the particle is decreasing. Okay, if f of x is defined by the graph below and consists of a semicircle and numerous line segment, evaluate the following. Okay, so I need to find the area under the curve of f of x plus 4. So there's different ways to do this. One would be, I can break this apart. I'm going to do it over here so I can have room for the other ones. Okay, so here's A. So this means find the area under the curve between 1 and 7. So that's half the circle with radius 3. So I'm going to have pi r squared divided by 2. And because it's below the x-axis, it's going to be negative. So I'm going to have negative 9 pi over 2. Okay. This, I can just do this algebraically. Find the antiderivative of 4, 4x, and I'm going from 1 to 7. So that's going to be 4 times 7 minus 4 times 1. So we have 9 pi over 2 plus 28 minus 4. So that would be the answer for A. For B, I have find the antiderivative from A to A of f of x. So I'm not going anywhere. My particle started at 8, it's ending at 8, so I didn't go anywhere. So that would be 0. Find the area under the curve from negative 3 to 7. So from negative 3 to 7. We already have this area. Okay, it is 9 pi over 2. So I don't have to find that. So that's good. So I just have to find this triangle. So triangle is 1/2 base times height, or height times base. And this is the area of the circle. So I'm going to have 2 minus 9/2 pi. And then for D, it says find the area under the curve from 10 to 7. For 1, first of all, I'm going to have to flip the lower and upper limits and making it into a negative, because I always have to go from smallest to largest, and I'm finding the area under the curve from 7 to 10. So that is this triangle right here. So once again, that's going to be negative 1/2 the base times the height that's going to give me negative 1/2 times 12, or negative 6. Okay, 20 says find the particular solution of the initial value problem. Once again, so this means find the antiderivative, and you're going to use these numbers to find me C. Okay, so I'm going to try to do u substitution first. So I'm going to let u be whatever's inside the function. So du is negative 3 dx. So negative 1 over 3 du is equal to dx. So notice that if I substitute, nothing's going to cancel. My x isn't going to cancel. I'm going to have a messy problem. So I'm going to have to do integration by parts. So I'm going to let u be something, dv be something. And the way I decide is by Lepet. So we have a polynomial and an exponent. So polynomial is u before an exponent. So because x eventually will hit 0, I can use the table. Okay, so the derivative of x is 1, the derivative of 1 is 0. The antiderivative of e to the negative 1, e to the negative 3x is negative 1/3 e to the negative 3x. The antiderivative of negative 1/3 e to the negative 3 is positive 1/9 e to the negative 3x. We're going to have plus, minus, plus, multiply going across. So this is going to give me negative x over 3 e to the negative 3x minus 1 over 9 e to the negative 3x plus c. Okay, so now we're going to use y and x to find c. So this is 0. So I have negative 1/9, or 3 plus 1/9, or 28 over 9. Okay, so my solution is going to be y is equal to negative x over 3 e to the negative 3x minus 1/9 e to the negative 3x plus 28 over